One of the many things that separates Earth from the other planets in our solar system is that the outer crust exists on multiple tectonic plates. This is something that has been going on for most of Earth's existence and is one of the driving forces behind the creation and destruction of continental and oceanic crust. It is the reason we've seen cycles of supercontinents and the separation of land masses. The solid crust sits on top of the mantle, which is a semi-solid layer that moves due to convection from the heat of the Earth's core, and this movement of the mantle is what moves the tectonic plates around the Earth. The number and movement of the tectonic plates has changed repeatedly throughout the past couple of millions of years, with plates smashing into each other, rifting apart, and others having to scrape past each other. And these just happen to be the three types of active tectonic boundaries that we see today, and also see evidence of in the past. These boundaries are known as convergent, divergent, and transform. Convergent boundaries are areas where the plates are moving towards each other and are kind of the most complicated of the lot. Where one of these boundaries is occurring, you'll usually find volcanic mountain ranges or volcanic island chains, a deep trench due to the presence of a subduction zone, and a high degree of seismic and volcanic activity. There are three types of convergent boundaries. Ocean to continental. This is where the denser and heavier oceanic crust is forced under the lighter and more buoyant continental crust. Here you'll have a deep ocean trench and a volcanic mountain range. Ocean to ocean. Here it's usually the oldest and denser oceanic crust that gets forced under the relatively lighter and younger oceanic crust. Again, you'll have a deep trench, but instead of a mountain range, you'll get volcanic activity that is purely underwater, or volcanic island arcs, or a combination of both. Continental to continental. Continental collisions occur at subduction zones where continental crust is forced together. Neither will subduct under the other, so what happens here is mountain building, but with very little volcanic activity. This is because when continents collide, subduction is dramatically reduced or ceased altogether. Over time, the plates may actually fuse together along this boundary and become one continent. The Ring of Fire is the most well-known group of ocean to continental and ocean to ocean boundaries, and the Himalayas are a brilliant example of continental to continental boundaries. Divergent boundaries are areas where plates are moving away from each other and are often called spreading centers or rift zones. At these boundaries, you get seismic activity and volcanic activity, but not to the same degree as convergent boundaries. However, these rift zones are unique because they are the only place where oceanic crust is currently being formed, and at mid-ocean ridges you get all manner of strange but amazing marine life. Currently, these boundaries exist as either mid-ocean ridges or continental rift zones, and continental rift zones that become established usually end up being mid-ocean ridges. So what happens along these boundaries is a weakening of the oceanic or continental crust, usually from the heat of the mantle, and this results in mantle upwelling and the crust getting pulled apart. Now, it's possible for rifting to start and then stop, so not every rift zone will become established. The East African rift zone is currently being watched to see if it becomes an established rift zone, while the Atlantic, Pacific, and Southern Oceans all have mid-ocean rift zones. Transform boundaries are places where plates are moving past each other. The majority of transform boundaries exist along the ocean floors, usually connected to rift zones, but there are a few bits of continental crust that are trying their best to scrape past each other. At these boundaries, there can be an incredible amount of seismic activity, but very little mountain building or volcanic activity. Unfortunately, the plate boundaries that are moving past each other aren't nice, clean, straight lines. There can be bends or things jutting out, and sometimes the plates can catch on each other. This can result in a buildup of stress as plates continue to try to move, and a release of that energy can result in a sudden but significant movement of the plates. The most famous transform boundary is, of course, the San Andreas Fault, but there are a few more around the world. Now, there are passive margins, which is where continental crust gives way to oceanic crust and there is no tectonic activity occurring. It is possible in the future that these margins may become active, just like it's possible for active margins to become passive. How and why this all happens is still a bit of an unknown. Plate tectonics and continental drift have really only been a thing since the 1920s, and we're at a bit of a disadvantage because these processes happen over millions of years.